Alright, so here's our guide through Chapter 7, and we're going to dive straight in with the main idea, and we'll put this in the filled out notes more descriptively, but the main idea of simplifying rational expressions, which is what we have here. Rational just means fractions. It means that we are going to only make sure that we are canceling or simplifying across the fraction bar when things are factored out. Now, the one other thing we need to say before we really dive in and run through these is Chapter 6 is vital for you to understand anything that's going on in Chapter 7. Every Chapter 7 question is some form of dealing with what we learned in Chapter 6. And so I won't belabor that any more than I did in class in our lecture, but let's go ahead and just dive in and see what we get. And we might even zoom in because the font gets a little small here. Okay, so for the first example, we've got 32c squared d to the 6th over negative 24c to the 4th d to the 7th. And really, in this one, it's going to be a little different than what we deal with. And sorry, I'm going to zoom back out just because it looks a little cleaner. Anyways, it's going to be a little different because we only have one term over one term. That's different than everything else you see on the page. So what do we do when it's one term over one term? Well, we really just reduce. 32 over 24 is going to be 4 over 3 when you reduce that by 8. The negative will transfer to the top or stay up front of the fraction. From there, what I'm going to do is I'm going to say we are going to cancel our c's. We have two c's on top, 4 on bottom. And when we cancel, there will be 2 left on bottom because we're ultimately subtracting, but where the larger number is will be where the positive leftovers are. Alright, now there are other ways to write that, and we can refer back to Chapter 5. You could have written c to the negative 2 up top and d to the negative 1st up top, but I like leaving your exponents positive. Your homework usually wants you to anyways, so we'll just kind of say where the larger number was is where the leftovers will stay. So 4th, 7th, they were left on the bottom and bottom with positive exponents. Okay, up next. Now, this one, it's tempting to look and say, oh, a squared, so those can cancel, or a's, those can cancel. And, or even just noticing 24 and 36, do they have something in common? And I don't want to say they don't. I mean, they do at some level, but more so, what we're going to do with every one of these problems is we're always going to say, is it factored out? And if it's not factored, if it's not multiplying ultimately as the key operation among the entirety of the numerator, then we're not going to cancel it with anything in the denominator. So we need everything to be factored out and multiplying, wrapped in parentheses or just a term out front, and then we'll factor. So what do I mean by that? Well, let's look at the numerator only. With 24 and 16, they share in 8. Also, a squared and a shared in a. And I'm left over with 3a minus 2. And so notice what I'm doing there again is I'm just dealing with the numerator as its own little Chapter 6 question, kind of like what I was saying. Then on the bottom, 36 and 24 share 12. A squared and a shared in a. And we're left with 3a, because that will give me 36a squared again. And then we're left with actually minus 2. And so now, take a look at this. I've got 8 times a times this whole parentheses. I've got 12 times a times this whole parentheses. And because I've got entire multiplied out, or I guess factored out things that are multiplying together in the numerator and denominator and they match, that's when they will cancel. So now the a's cancel, and also 8 over 12 turns into 2 over 3. Now, I'm going to caveat this, kind of say asterisk. There are a few numbers that are exceptions, specifically 0 and, what would that be, 2/3. But besides 0 and 2/3, kind of the idea of, again, what this whole chapter is about is I could tell you to plug in 7 or 28 or 36, and it turns out no matter what, you would have gotten 2/3. And that's really the power of what we're doing is we're saying you can probably write this in a much simpler way that would involve less steps if you had to, what we call evaluate it, plug something into it, and it'd be nice to know what that simplified form is. Kind of keep that in the back of your mind as the motivation of why are we doing this? If I had to plug something in, it'd be nice to know I would essentially just get 2/3 almost every single time again, except for if I plugged in 0 or 2/3, and well, that's what college algebra is about. Anywho, let's continue on. We've got more factoring, and again, we're just going to go more quickly through that factoring and just review the answers to make sure you have them. So, up first, we are looking for the factors of 18 that subtract 3, and those are going to be 6 and 3. And the 6 is going to be have to be positive, and the 3 is going to have to be negative. On the bottom, we're looking for the factors of 6 that subtract to 1, and that would be 3 and 2. And the 3 will need to be negative, and the 2 will have to be positive. Again, because I'm trying to make negative 1 in the middle and negative 6 at the final multiplying, and I'm trying to make positive 3 in the middle and negative 18 through the multiplying. Now from there, what do we notice? We notice that the c minus 3 is written on the top and on the bottom, and it's multiplied and multiplied. So therefore, because it's multiplying everywhere on top, multiplying everywhere on bottom, they cancel out, and we're left with c plus 6 over c plus 2. Now it's tempting to say, oh wait, I see some common c's, let's cancel them, or I see 6 and 2 reduced to 3. But whoa, because we are no longer multiplying in these terms. They're adding and adding, so there's no canceling across the fraction bar. All right. More factoring techniques from chapter 6. The top is a difference of squares. You're going to be left with 3x minus 5y, 3x plus 5y. Hopefully just through me saying that, you're realizing how much chapter 6 is really the crux of being able to get through this. On the bottom, we're going to do by grouping, but we're even going to, and I'm not remembering the answer as I do this, but we are going to be essentially factoring by grouping. Now what we can do is we can start to guess our answer. It could either be 6x and 1x, but just because I'm trying to make 5 a relatively small number in the middle, it just feels like it's going to be 2x and 3x. And I'm not sure about that, but we'll figure out. So now that I've got 2x and 3x, the question is it 1 and 25 or is it 5 and 5? And again, because I'm trying to make a small number in the middle, if I had 1 and 25, I'd be making either 50 or 75 with that 25 in either of these places. And again, just to reiterate what I'm doing is I'm really talking through what are all the options this could be. It could be 6x and x, 1 and 25, or 6x and x, 25 and 1. It could be 2x and 3x, 1 and 25, 2x and 3x, 25 and 1. It could also be 6x and x and 5 and 5. It could also be 2x and 3x and 5 and 5. And again, with time and practice, I'm really guessing and checking as I talk you through this, kind of mentally as I go. But it just feels like this needs to be 5 and 5, because after all, we need to subtract to make 5 in the middle. So the number should be relatively close to kind of almost cancel out or be relatively small. And take a look, when I multiply these out, that would be 10xy, that'd be 15xy, and yep, I can make negative 5 out of 10 and 15. I just need the 10 to be the positive of the two, so that will make positive 10, and I need the 15 to be the negative of the 2, and trust me, you can refoil that out, or again, you can go through the whole by grouping process like we did in chapter 6. We had a question similar to this where it was by grouping with some y's and y squareds. You can do the by grouping, and in fact we did it together in class, but I want to show you again, this is really kind of towards the end of chapter 7, and as you get comfortable, you should really almost be guessing and checking your answers. It can sometimes be faster than the whole process. Anyways, 3x plus 5y and 3x plus 5y is written entirely on the top and on the bottom. They're factored out, multiplying everywhere, so they cancel, so we're left with 3x minus 5y over 2x minus 5y. Again, don't cancel out those negative 5y's because they are not multiplying together, they are subtracting from a 3x and from a 2x. And if they're not entirely multiplying to everything, they cannot cancel. Alright. Up next, this is a difference of cubes, so we're just going to run through that difference of cubes formula. Again, look to chapter 6. We use the cube rooted forms in the first parentheses, so just x and just 1. And then the way we read that formula is we say we square the first thing, we square the last thing, we multiply them, which is 1x, and use the opposite sign of what we wrote first. Again, the formula technically reads that way, but you need to kind of see it as a mathematician to say it that way. Use the rooted value, use the rooted value, sign that you saw already, square that first thing, square that last thing, multiply them, and switch the sign. Is really the way the formula reads, kind of with time and practice. Up next, another quick by grouping, because fortunately 3 and 7 aren't very factorable. It has to be 3x and x. And then the question, is it 1 and 7 or is it 7 and 1? Well, this would make 21 and 1. I can't make 4 out of 21 and 1. Again, I'm just fast foiling in my head. So then it must be, if it's going to work at all, if this is factorable, 7 and 1. And I can make 3 and 7, and I can subtract to make 4, right? Read the regular factoring sentence. What's going to subtract to make 4? And 3 and 7 can subtract to make 4. as long as the 7 is negative and the 3 is positive. And again, if you FOIL that out, you'll see why that makes 3x squared, and collectively negative 4x in the middle and negative 7 at the end. Now what's shared once again is the x plus 1, or not once again, but what's shared, now that we notice that, there is something shared and it is the x plus 1. And so we're left with x squared minus x plus 1 over 3x minus 7. Alright. Up next, this next one, just like the rest, we are looking at numerator only, denominator only, and factoring. Now I'm going to do this a little quick, but we are doing by grouping in the top and on the bottom. And so here's the way I'm going to say it. Actually, you know what? It's worth, we can do this first one written out. First, we notice there's a shared a in the first two terms. And we can get b plus 5 if we take out a negative 3 from the next two terms. So the first is, again, what's my common factor? The second is, how do I produce a match? On the bottom, the first two share is a b. We're left with c minus 2. And I can create a match of c minus 2 if I take out a positive 5. Alright. Up next, what do I collectively have? Well, I have a b plus 5 in common on top, leaving an a and a minus 3. On the bottom, in common, I have a c minus 2. And so I'm left over with the b plus 5. And so once again, the b plus 5s cancel. We have a minus 3 over c minus 2, and we are done. All right, one page down. Up next, we're going to introduce the idea that you could be multiplying two entire fractions together, and that won't be too bad. It's really just now, instead of doing one problem per page, we're doing like two problems per page compared to what we did on the last slide page. So here we go. I'm going to first treat each one of these as a question like the last page. So 30 and 42, they share a 6. I'd be left with 5 over 7. Once again, if I play kind of the exponent subtraction game, a 3 and a 2 will leave a 1 on top, a 2 and a 1 will leave a 1 on top, and a 1 and a 2 will leave a 1 on the bottom by subtraction. Similarly, 15 and 25 reduce to 3 and 5. 2 x's on top and 4 on the bottom will leave 2 on the bottom. 2 on top, 1 on bottom will leave 1 on top. And 2 on top, 1 on bottom will leave 1 on top. Now, it's kind of up to you how you want to see this next step, but what I'm going to do is I'm just going to say it out loud that now there's 5s that are in common, which will totally cancel. So the 5s have canceled, so there's really just a negative 3 left on top. There's also an x and an x squared, so as long as it's on top somewhere and on bottom somewhere, again, because we're only multiplying now, we can cancel stuff. So the 5s cancel. X and x squared will cancel to leave 1x on the bottom. A y and a y will make a y squared. And a z on top and a z on bottom will actually cancel out entirely, and so let me kind of rephrase that. 7 now is left over. A z canceled out with a z already, and the x is canceled out, and there's 1 left on bottom. So, in other words, I can cancel out those 5s early. I can cancel out this x with the x squared. I can cancel out the z with the z, and that's really where we're getting that final answer. A negative 3y squared, and a 7 on the bottom with an x to the first. All right, so we can cancel that as we go. All right, up next, now is where we're really diving into, like, again, a bunch of Chapter 6 questions. I've got a difference of squares on the top left. And again, that's the other strategy, is don't get overwhelmed by seeing all the stuff here. It's top left, bottom left, common 6. And then it's, well, what's on the top right? I've got a common 5. And bottom right, I've got another difference of squares. All right. Now, the way we're going to phrase that now is that as long as it's on the top somewhere and on the bottom somewhere, since everything is multiplying, big multiplication, dot, multiplying and multiplying, same thing, multiplying, big multiplication, dot, multiplying. As long as something's on the top and I see a match on the bottom, since all we're doing is multiplying, then we can cancel them kind of early, so to speak. So the x plus 3's cancel, and x minus 5 cancels. And so I'm left with 5 in the x plus 3, or x minus 3, sorry. And on the bottom, I'm left with the 6 and the x plus 5. And we're done. There's no more like terms there. Again, I just gotta say, it's tempting to see the 5 and 5. Do they cancel? No, they don't, because this 5 is multiplying, but this 5 is adding within parentheses. That 5 is not multiplying to everything else. It's multiplying to 6 at some point, but it's not multiplying to the x. So since it's not multiplying entirely, 5s don't go. It has to be an exact match, factored out top and bottom to kind of cancel. Or it's got to be like a common factor because there's only one term and they're just coefficients. All right, up next, this is where things get really, really challenging. Again, you're going to have to be really comfortable with Chapter 6 to be able to see what's going on here, but we're going to say it. We've got 3 by grouping questions that I'm going to, again, kind of guess and check. And then we've actually got a regular factoring question, so maybe we'll warm up with that one. So first, factors of 8 that add to 6 are 4 and 2. They both need to be positive to make positive 6 in the middle and positive 8 by multiplying at the end. Then we've got this 8x squared and negative 3. And there's not a lot of ways to make 8. There's 1 and 8, and there's 2 and 4. It feels like it's a 2 and 4 combo. I could be wrong. And then, is it 3 and 1? Actually, I think it is 3 and 1, because that makes 12. This makes 2. And I can subtract to make 10 by 12 and 2. Again, I'm just foiling really quickly. So 12, or 4 times 3 makes 12. I need that to be positive to make 10 in the middle. And I need a negative 2 to cancel and just make the 10. So there we go. On the bottom, there's not a lot of ways to make 3x squared. There's 3x and x. Now there's a few ways to make 4s at 1 and 4 or 4 and 1. Once again, it feels like it's a 2 and 2 case where I've got 6 and 2, and yep, I can make 4 by subtracting. The 6 has to be positive. The 2 has to be negative. Notice I'm saying that kind of as I'm foiling it. That's the positive 6, the 3x times the 2. This is the negative 2, the negative 2 times 1. On the bottom right, we've got another, again, foiling. 2x and x can only be made by 2x and x. And 12, well, that could be a lot. It could be 1 and 12, but I'm thinking about that. That'd be like 24 and 1. Can't make 11 out of that. If it was 6 and 2, that'd be 12 and 2. I can't make 11 out of that. If it was 4 and 3, that feels right. That'd be 8 and 3, and I can add to make 11 out of those. They both have to be positive. All right. So again, that's all Chapter 6, and I know I'm going through it quick, but Chapter 6. Go ahead and go back, pause. If you feel super lost right now, it's not because of the Chapter 7 context. It's because of the Chapter 6 examples we did before. So now the question is, again, what's on top, what's on bottom? There's a 2x plus 3 on top. It's a 2x plus 3 on the bottom. Wherever they are, as long as everything is multiplying and everything is multiplying, it can cancel as long as it's somewhere on top and somewhere on bottom. X plus 4, gone. X plus 2, gone. So we're left with 4x minus 1 over 3x minus 2. And we're good to go. All right, now when we get to dividing fractions, really the idea is we're just keep change flipping. So for the first one, I'm going to reduce as I go. I've got 5 over 6. I've got c cubed. I've got g to the first. Just doing my subtraction. What I'm going to do now, though, is I'm just going to write multiplied by c squared g cubed over 5cg squared. And so we kept, although I did reduce as I kept, changed to multiplication and flipped my fraction. Now that I flipped the fraction, now I'm going to kind of deal with this one over here. So still my 5 over 6 c cubed g, but now I've got my 4/5, and I've got 1c left on top and 1g left on top. And when I work that out now, I've got 5s and 5s. I've got a 4 and 6, which will reduce to 2/3. And so it looks like I've got 2c to the 4th g squared over 3. All right, so really, division of fractions just means keep, change, flip, and we're not doing anything other than we did in the example above. So this one will look even more like that. Now, I'm going to be kind of quick here in factor as I flip, so be careful about that. I am factoring as I flip. So first I've got common factor factoring. All right, so I'm keeping, but I'm factoring as I go. Now I'm changing and flipping. So what was the bottom is what multiplies to 9 and adds to 6, and that's 3 and 3. So I'm flipping that. Sorry, that should be a W. So what multiplies to 9 and adds to 6 is 3 and 3, but they both need to be negative. Now again, this is the one from the denominator, but it flipped as I factored it, so now it's up top. Now it's what multiplies to 9 and adds to 6. Well, it's actually still 3 and 3, but the sign's going to be different in the middle. They're both going to be pluses. And again, that would have been for what's on top, but because I'm keep changing and flipping, now what I factored is on the bottom. I'm just trying to save a line or two. Okay, now as long as there's something on top, W minus 3, they cancel. A W plus 3 with the W plus 3 cancels. And you can only cancel 1 for 1, right? You can't take this extra W minus 3 with it or something. Only 1 for 1. And so we're left with 5 W minus 3 over 3 W plus 3. And we're done because not everything is a perfect match multiplied out on top and bottom. So that's as simple as it gets. All right, now this time it is a bunch of by grouping, kind of like what we saw last time. And so just kind of trust me here that I'm going to factor as I go just to kind of be a check for our work as we go through this. So first I see an x that's shared, and so watch how I'm going to write this. I see the x is shared, and I'd be left with y minus 3. And so what I'm doing is I'm kind of inferring already. I know I should be able to get y minus 3 out of this, and yes, if I take out a positive 4. And so you, again, can double check that. That makes xy, negative 3x, positive 4y, negative 12. I'm good to go. But kind of notice what I did there was I kind of wrote down what I knew was the common factor and what's left over. And then I just said, well, what's the other thing I need to make a match? And I dumped it right into the parentheses. So we're just going to do that through all these. So what do I see in common? I see an x. What am I left with? A y plus 6. Can I form y plus 6? Yes, if I take out negative 3. And again, you can verify that that foils out to the correct answer. Flipping and factoring as I go, what was on the bottom had a x in common, leaving you with a y plus 5. Again, it was on the bottom, it's moving to the top. How do I make a match? I take out a negative 3, and then I'll get my matching y plus 5. Again, it was on the bottom, now it's on top. What was on top? Well, there's an x shared, leaving you with a y plus 5. And how do I make a match? I take out a positive 4. And I'll be left with a y plus 5. Again, it was on the top, now it's on the bottom as I factored it. Now we play the matching game. There's an x plus 4 on top, x plus 4 on bottom, x minus 3 on bottom, x minus 3 on top, y plus 5 on top, y plus 5 on bottom. So I'm left with y minus 3 over y plus 6. So I know we did that by grouping really, really fast, but it's first two, last two, make your match. First two, last two, make your match, so on and so forth. This one's actually a little easier because none of those numbers are like squared or cubed, or none of those variables rather are squared or cubed, so it actually makes the math a little simpler. Awesome. All right, up next, just some quick evaluating of these. Now, you can do this either way you want, but honestly, we'll just plug it in directly and see what happens. I am going to simplify as I go here, though. Negative 3 squared is positive 9. Then negative 3 substituted is negative 3, and then there's negative 6 on the bottom. On the bottom, negative 3 squared is still positive 9. Negative 3 just plugged in as negative 3, and then that's negative 12. So it looks like I get, let's see here, 9 minus 3 minus 6 is 0. Over 9 minus 3 minus 6 is negative 6. So really that's still just 0. All right, and then from there, we can just go quickly. I'm going to do this super quick. 25 plus 5 minus 6 is 24. 25 plus 5 minus 12 is 18. And so I've got 4 over 3. Again, I know I'm working that out quick, but really this is just plugging in and doing some quick PEMDAS. Just plug in 5, 25 plus 5 minus 6. Plug in 5, 25 plus 5 minus 12. And there we go, 24 over 18 reduces because it has a 6 in common. On the last one, we plug in 3, and it's almost the same, but we'll see, why caring about your sign matters. 3 squared is 9, plus 3 plus 6, minus 6, sorry. And then on the bottom, we've got 9 plus 3 minus 12, and this time it looks like what I get is 6 over 0. And remember, we have a special name for that. We call that undefined. All right, so just be careful about that. Now, there's other things we could do to approach that problem, but really for now, we don't need to worry about that. All right, 7.2, we spent a lot of time in class together kind of discussing the necessities of how we go through this process. And, that's why we attend lecture. But from there, what we're going to do is we're going to review this process of adding or subtracting fractions. There's lots of things to be careful of and consider, but the first few examples aren't too bad, and they're going to warm us up. So the first thing to remember is that you can only add or subtract fractions when you have common denominators. But look at this first question. They are common denominators. And so step one is just writing one big fraction with your common denominator. After all, if it's common, you don't need to write it, twice. And so that's step one. Well, now that I've written it over the common denominator, I see some like terms. I see a 4p and a 2p, that makes 6p. I see a negative 3q and a negative 5q, that's negative 8q. And that's over, once again, 3p minus 2q. Now, this one is really tempting. It just seems like, I should be able to reduce this. But remember, the 6 has a 2 and a 3 in common, and so there's not a 2 shared across everything. This one's missing a 2. 6 has a 3 also. 8 doesn't have a 3, and 2 doesn't have a 3. Not everything has a p in it, not everything has a q in it, and especially not everything is written factored out in parentheses. So there's really, as tempting as it looks, there's no simplifying this because there's nothing that's shared across all your terms. And even if, just to show this, even if you felt like factoring out the common 2 from the numerator, that's actually almost, although it's a little extra work for no reason, it's further evidence that because this is not an exact entire match, that's why nothing is canceling. All right, so there we go. Up next, let's see this next one. I still have my common denominator to start, but now the question is, what does a minus sign do? And that's a callback to chapter 5 where we learned how to subtract our polynomials. So when you subtract the right-hand fraction, you subtract the entire right-hand numerator, or in other words, you distribute that negative through the right-hand numerator. So now I've got a squared plus a minus 6 on top over a squared plus 3a minus 10. Now this is tricky because now, once again, we're in factoring territory. There are factors of 6 that subtract a 1. They're 3 and 2. There are factors of 10 that subtract a 3. They're 5 and 2. And let's see here if I think back through these. The 3 needs to be positive and the 2 needs to be negative, so be a positive 1 in the middle and negative 6 by multiplying. And this one, the 5 needs to be positive and 2 needs to be negative for similar reasons. And look at that, the a minus 2's cancel, so we're finally left with a plus 3 over a plus 5. Awesome. So what we learned in this example is, again, if you have a common denominator, you're ready to write one fraction. But when you subtract the right-hand side, if you subtract the right-hand side, the negative distributes to both parts. And then whatever you're left over with, you need to ask, can I factor the top and bottom like a chapter 6 question? Even after all that work, you still need to ask that question to make sure you're simplifying correctly. From there, we've got a series of more examples to go through. So we're going to find lots of ways to get our common denominator. So for this first example, if you think about it, all right, 15 is made of 3 and 5. 9 is made of 3 and 3. And so when you ask, what does one denominator have that the other needs, here's the way I'm going to say it. This denominator has a 3 and 5, but it's missing the second 3 that I see on this side. So we're going to multiply that second 3 over to the left-hand side. On the right-hand side, 3 and 3 makes 9, but I'm missing the 5 that I see over here. So that's what we're going to multiply over here. We're going to multiply the missing 5 over 5. They both already had a v, so that was shared. So what do we get now? We get 18. We get a big minus sign, and then 4 times 5 is 20. That's only one term, so we don't need parentheses there. And it's over, well, we actually just got common denominators, because 3 times 15 is 45v, and 9 times 5 is also 45v. And so I now have a common denominator of 45v. What do I get when I simplify? I get negative 2, because that's what my numerators are combined, over 45v, and we're done. So we're just getting common denominators. And notice what I had to do here to kind of help myself. I had to, diagnose 15. What is 15? It's a 3 and a 5. What is 9? It's a 3 and a 3. So this side has 2 3s. Does this have 2 3s? Nope, so give it the second 3. This side has a 5. Does this have a 5? No, so give it the 5. You're passing each other's denominator what the other thing needs, but notice we're multiplying again by like 3 over 3 or 5 over 5 or something over something, so that we're really just multiplying by 1 if that's clicking there. And hopefully we'll see that through other examples. Up next, this one is kind of tricky, but once again, 16 is 4 and 4, and 12 is 4 and 3. So we're kind of in a similar situation where this has a 3 on the right, but this doesn't at all. So we're definitely going to multiply a 3 over 3. Now, wait a minute, because there is some more stuff to do here. At least there might be. There's something to do somewhere, because I'm kind of looking ahead. So now what I'm looking at is I'm looking at the variables. I see that this left side has 5 s's and this has 2. So this already has more than enough, so to speak. But this has 2 t's and this has 1. So I need an additional t to get me 3 t's on the left-hand side. From there, let's deal with the right-hand side. Oops. I always want to write the s first. Alright, so this time, over here, and I'm running out of space a little bit here, but this side has 2 4s. The right-hand side only has 1, so this needs the second 4. It also needs the s cubed. Sorry, I'm running out of space there, but it needs the s cubed. Because both of them need to have at least 5 s's, and this one already has 3 t's. This one needed to get up to 3 t's, so I just kept the t cubed there. So let's see what we have now. Let's work that out. I'm going to actually write it like this, just because that was getting a little small. Plus, now let's hear 2t minus 7 times 4s cubed. So that's my new numerator, and you can kind of see I'm going to distribute that to the left side. I'm going to distribute the 4s cubed to the right side, but it's now all over my common denominator of, I feel like being lazy, 3 times 4 times 4, right? I know that's what I have because there is a 4 times 4 and I just made a 3. I know there's going to be 5 s's because that's the most I saw, and 3 t's because that's the most I saw. So, in other words, also, if you look at this, I did make my common denominator. That is 3 times 4 times 4. That is s to the 5th in t cubed. So there it is. I have 4 times 3 times 4 in some order. I have s to the 5th now that I multiplied an s cubed, and I already had t cubed. So there we go. Sorry, I'm going to have s to the 5th because I had s squared and now I'm multiplying s cubed to get s to the 5th. Okay, what do we do now? Well, now we're going to need to carefully distribute our numerators. That's going to be 15t squared minus 24t. If I distribute this, it's going to be plus 8ts cubed, and then that's going to be minus 28s cubed. All of that is going to be over my common denominator of 3 times 4 times 4 times s to the 5th times t cubed. Now this is your final answer, but we need to kind of talk through why for a second. And you might be thinking, well, wait, there's 4 terms, let me factor by grouping, but that would actually just take you back to what we had right up here. Also, then here's what you need to kind of ask yourself to assure yourself that you're done. This 3 is multiplying on the bottom. Does everything have a 3 up here? No, 28 does not have a 3 multiplied to it, neither does 8. What about 4? Well, 15 doesn't have a 4 in it. 15 doesn't have a 4 in it. There's an s to the 5th, but not everything even has an s. There's a t cubed, but not everything has a t. So believe it or not, this, as ugly as it is your most simplified form, because you always have to ask yourself what is multiplied and completely distributed, or I guess factored out, so that it would distribute to the entire problem. Your numerator doesn't have anything that can be entirely factored out and grouped together, so we're actually done right there. All right, let's keep going. This next one's, I would imagine, going to be a little bit easier. So I can notice the common 2 in my denominator on the left. Whoops. And I can notice the common 6 in my denominator on the right. And this is actually really good news because at first those denominators looked pretty different from one another. But what I actually see is they actually both share the y minus 4. They actually both have a 2 if you can think about it that way. So really we just need a 3 over 3 to the left fraction. It's the only thing keeping us from being common. And once again, just be aware that the only reason we can really diagnose that or notice that is because we factored out the denominators. Before that, it's kind of unclear what one part has and the other needs. But again, you can really see that would make 6y minus 4. I have 6y minus 4. So now that I've done this, I'm going to still FOIL and distribute, but that'll be 3y minus 9 when I distribute over the common 6y minus 4, because I just made that on this side and I already had it over here. And also be careful of this. When I distribute that negative y, it's now going to be negative y, but it's going to be positive 7 because I'm distributing that negative to both parts of the right numerator. From there, 3y minus y is 2y. Negative 9 plus 7 is negative 2. I've got a 6y minus 4. Darn, I thought I was done, but I'm going to quickly write the final answer here. I'm noticing that there is that's an equal sign, not like a minus out front, just to make that look clear. What I'm noticing, though, is that there is a shared 2 in the numerator. So if I factor out that 2, I'd be left with y minus 1. But because I factored out the 2, I see that it's going to reduce with the 6. So I said that out loud, but let me just say it again. There's a 2 that was factoring out, and 2 over 6 is 1/3. So now I'm left with the y minus 1, and the y minus 4 just stays there as before. So we took out a 2 from the numerator and canceled it, leaving us with just y minus 1 in the numerator and just 3 in the y minus 4 in the denominator. All right. Up next, again, we're just kind of keep going, and really, I hope you notice how much Chapter 6 is important. The reason we're going so fast is because we're assuming you've memorized all of the factoring techniques. We've been a lot slower through those in the Chapter 6 video, so visit them again if you have to, but again, let's keep on moving. This first one, the denominator doesn't factor, but on the right, the denominator definitely can factor to x minus 5, x plus 4. And so what that does is that once again tells us that, hey, we're actually not that different. This whole thing just needs the x plus 4. Just to kind of save some work there. X times x is x squared. 4 times x is 4x. A negative to that whole thing is, well, actually just negative 45. And I already have a common denominator. X minus 5, x plus 4. And unfortunately, this this numerator can factor. There are factors of 45 that subtract to 4. It's positive 9 and negative 5. So they cancel. And so we have x plus 9 over x plus 4. Great. All right. This next one is probably one of the more intense ones, but it's definitely worth doing. It's one that you'll definitely see in kind of a college algebra setting. So first thing, that shouldn't be 82. That should be 8w. Just the 2 and w are next to each other, so sorry about that. That's 8w. But let's keep on going. So first, we're going to factor, and the factors of 24 that add to 2 are 6. Sorry, subtract to 2 are 6 and 4. said it wrong, factored it right, because again, those make positive 2 in the middle and make negative 24 by multiplying. Up next, I've got the w minus 8, and the factors of 16 that add to 8 are 4 and 4, but they're both going to be negative. All right. Now this one is definitely going to be intense because we need to deal with, really a lot. We're going to have to distribute and FOIL a lot because I see 2 shared w minus 4s, but the left-hand side only has 1 w minus 4, so it needs an additional w minus 4 in order to become common. On the right-hand side, I see 2 w minus 4s, and now I see 2 w minus 4s, but I also see a w plus 6, and that's not over here, so I need the w plus 6. All right, now that we have our common denominator, I'm going to write it like this. And I might start writing some squiggles here. But there's my common denominator. And on the left, I need to FOIL this whole thing out. So I'm going to kind of say it and simplify it as I go. I get w squared. I get a negative 2w and negative 4w, which makes negative 6w. I get negative 4 times negative 2, which is positive 8. There is a plus sign, so great, no parentheses and distributing after I FOIL, but w times w is, once again, w squared. That'll be positive 6w and negative 8w, which makes negative 2w. And then I get negative 48 from the final multiplying there. All right. I'm then going to combine my terms. So I've got a w squared and a w squared. That's 2w squared. I've got a negative 6 and negative 2. That's negative 8w. I've got a positive 8 and negative 48. That's negative 40. And this is where I'm going to bring about my famous squiggle because I already know what the denominator is. It's w minus 4, w minus 4, w plus 6. And so I'm just going to, for sake of time, just say, I know what that is. That's not what I'm working on. I'm working on these numerators right now. So continuing, I'm noticing there's a 2 shared. And that would be this. And again, over that same denominator, w minus 4, w minus 4, w plus 6. Now the question is, are there factors of 20 that subtract to 4? And let me think about that. The factors of 20 that subtract to 4, well, there's 1 and 20, but those don't subtract to 4. There's 2 and 10, but those don't subtract to 4. And there's 4 and 5, and those don't subtract to 4. So I'm pretty sure this doesn't actually factor. And so that's my confirmation that I tried to factor it, and I was unsuccessful. Now, also, I could be a lazy mathematician and write w minus 4 squared. You don't have to. You could write it out twice, but I'm feeling lazy and wanting to write faster. So there we go. And I don't know. I kind of thought this one might simplify more, so I'm just going to double check my work and then we'll keep going. All right. And I was able to confirm that that is indeed the correct answer, but it's always nice to try to factor and see if it can cancel. You never know if there's going to be something that goes away, like what we did in the last section. Okay. Kind of last section here. I was kind of running out of space here and writing all over the place, but the good news is this one doesn't look to be too bad so far. But I do need to leave some extra space, a lot of extra space between each term, so I can see what's about to happen. And again, I gotta leave some extra space. Minus 3 over, and so far the only one of my denominators that can factor is the last one, and believe it or not, there's a y shared, and I'm left with the y plus 5, and so that's actually kind of interesting there, and that's really our clue, is that what's my common denominator? Well, it is the y times y plus 5, and so really, in other words, what we could say is this denominator over here is already ready to go. It has everything. This is just missing parts, and so also, I mean, hopefully it's been obvious what we're doing, but just in case, it's good to remind yourself that the only way to make common denominators is through multiplication. You can't just put a plus 5 here and a plus 5 here. It will not work. You have to do it via multiplication. Hopefully that's obvious because that's all we have been doing, but I just need to say it out loud in case we've missed that, because you can't just add two things to get a similar fraction. you have to multiply by 1, essentially, right? And that's what we've been doing this whole time. I've been multiplying by something over something. And by doing that, I'm never changing the value of this fraction, but I'm changing its appearance. This one just needs the y over y. And because of that, maybe we'll write it in parentheses just to kind of show what's about to happen here. All right, well, I definitely have a common denominator now. It is the y and the y plus 5. Each one of my denominators has that. There's the y and the y plus 5. There's the y plus 5 and the y, but multiplication can be done in any order. And there's the y and the y plus 5. So my denominator's common. That's not the worry. But now let's work on my numerators. 3 times y is 3y. 3 times 5 is 15. 2y times y is 2y squared. Negative 5 times y is negative 5y. And a negative entirely 3 at the end. Now, if there were more terms, again, make sure you distribute that negative throughout. But let's see what's next. What's next is, well, a 2y squared, a negative 2y, and it looks like a positive 12. And we're left with y plus 5. From there, it looks like maybe there's opportunity to factor, so let's double check. If I divide out of 2, I'm left with this. And so now I'm stopping and asking myself, are there factors of 6 that add to 1? Well, there's 1 and 6, but those add to 7. There's 2 and 3, but those add to 5, right? 2 and 3 could subtract to 1, but this says the factors of 6 need to add to 1. And 2 and 3 add to 5, 1 and 6 add to 7. So none of them work, and so this is actually as simple as it gets because I couldn't factor anything else that made an exact match. Awesome. Okay. For sake of time, we're going to skip over this section because I guess, well, just to write it out, we'll write it out just once. All we're saying here is this. I already see the common denominator, and so I've got x squared minus 2x plus 4 plus 5x minus 8, and I'm trusting you could combine your like terms and try to factor that after. On the bottom, I'm going to write it like this. I've got my x squared minus 2x plus 4 minus parentheses 5x minus 8. But that's still going to be over your common denominator, x minus 4. And I guess I'll just leave those as your two starters, and I'll leave that third one as a challenge. I'm also going to leave this extra word problem. Well, no, we'll work it out. But they don't want us to actually solve it, but they really just want us to show what this would be. So if you read through the question, it's saying Frank can do some portion of t over 5 hours of a house, and Jose can do some portion t over 3 of a house, and we want a way to express what both of them can do together. And the idea is, well, when they're both working together, they're additive, or they're adding to one another. And, well, guess what? I need to make common denominators. I'm going to do that super quick. That would make 3t over 15, because I just multiply by 3 over 3. Multiply this by 5 over 5, and I also get 15. And so the way they work together is 8t over 15. That is the ratio we need to figure out how much they've done together. So, great. Nothing too complex there, but just be comfortable realizing that you are going to be adding these fractions together. And they'll make an appearance again in a little bit with Chapter 5. Okay. 7.3 is where we'll stop for this video, but we will go through the first 3 examples. This last one is, I'm going to kind of say a challenge question, but really it's only going to appear in your homework, and in fact 7.3 won't be on your exam itself. So these should go by pretty quickly because it turns out that when you have fractions over fractions, you're really just shorthanding this format. And so at that point, you should go, oh, so top divided by bottom, top divided by bottom. And then you just say, well, then I'm going to do keep, change, flip. And guess what? 8 and 12 can cross-reduce. And that goes back to the idea of if you see something on top that can reduce or cancel with something on the bottom, why not go ahead and do it early on? We would get 22 over 9. And you have a calculator, again, that you can verify that with, so I'm not too worried about that. But great. So fraction over fraction is just keep, change, flip all over again. So in fact, we could even be lazy and not even write out the initial fraction divided by fraction and move straight to the top is what's kept. We then change to multiplication and we flip the bottom. All right, great. Well, r on top is just one r on top. 2 s's and 5 s's will leave 3 s's on the bottom. And a t on the bottom with nothing else will stay a t on the bottom. And we're done already. So some of those go pretty quick. And in fact, I think they go so quick that I think you could do this one. I will say this one is going to be probably the nightmare problem. And I'm just going to say verbally what you're going to need to notice is that the first thing you're going to need to do is create common denominators in the numerator and then common denominators in the denominator, and maybe even notice some factoring that you can do. But again, this is really just, I would call the challenge section, and this will not show up on the exam, so I'm just going to skip over that one for now. So that's enough for this video, and the next one we'll go over 7.4 and 7.5.